Hi, welcome to CSE114 Introduction to Object-Oriented Programming, and we are on exceptions. So in the last video lecture I introduced you to exceptions and I showed some demo in which we learned about exceptions, like how the exceptions can occur and how should we handle the exceptions. And I stopped on this slide, so I will start from the next slide. So let's learn about exceptions more systematically, like how should we write exception, and if we are using exception in our program, then what are the different things involved in writing a program with exception. So it's a very general example where you can see, let me use my pen. Here we go. Alright, so if you're paying attention to these two boxes, then we have method 1 in box number 1 I can call, and then we have box number 2. I will change the color. Okay, I'm more comfortable with blue ink. Alright, so method 1 is in the left box and the method number 2 is on the right hand side. So what is happening in this case? In method 1, if you look at, then we have the try and catch block, and try and catch is used in handling exception in Java. Now so when you put a method to invocation, so this is a general code and we are using statements like invoke method 2, so that you should assume that we have something like that. You will say method in parentheses, that's how you will invoke, but let's assume that we are invoking method 2 here. So since the method 2 has this capability of throwing exception, so we should put that statement which invokes method 2 in the try block. So all those statements which may raise exception should go in the try block, and after the try block we write a catch block, and the catch block has a parenthesis in which we will we denote the kind of exception that we are capable of handling here. So here the kind of exception that method 1 can handle is of exception type. Okay, so that's the reason in the catch block we have in parentheses exception, which is the name of the exception class, and ex is the object in which you will capture the exception if that is raised by method 2. So this try and catch is what we have in main method. In the try block we have the invocation of method number 2, and the catch block we have the code that will take care of handling this exception. Now let's move on to method number 2 and try to understand like what do we have in method 2. So the first thing that you should notice is about the declaration of method 2. So method 2 has been written with this extension which is throws exception. So whenever you declare a method with this information that it throws an exception, then that will give an idea that this method may involve a situation in which the exception may be raised, and this method does not have the capability of handling the exception. So it's the responsibility of a method which is invoking method 2 to take care of the exception. Okay, so for that reason method 2 has been declared differently, and we write method 2 followed by throws exception, so which in fact is declaring. It's a declaration of the fact that the method 2 may raise exception. Okay, and this is the exception type. Exception type is exception class. Alright, so this is again a very general code, just like the way we have in method 1. Now what do we have in method 2? In method 2 we are checking for the condition. If there is an error, if an error occurs, that means if there is the condition of the exception, then what we have to do, we will create, here we are creating an exception object. You create an exception object, exception object. Alright, so here if you pay attention to new and exception, that means you're creating an exception with the help of new keyword, just the way we create any object from any class. So here the object that we are creating is of exception type, is of type exception class. So you'll say new exception, and whichever object you are creating, you need to throw that. Throw that means pass that exception back to the invoking method, which is the method 1. Alright, so this is an interesting example which is general but is highlighting the different important things which are involved in handling exception. So first is declaring, which we have right here. So this is the declaration right here, and we declare exception in the class in the method where we may have an exception. Throwing takes place in that method itself where exception will take place. So you check for the condition of an exception, and if the condition is true, then you create an exception object and you throw that using the keyword throw. And once that is thrown, then this thrown exception would be caught by the invoking method, which is method 1 in this case. Right, so how will that do? It will catch that with the help of the catch statement. Okay, so the method invocation goes in the try block and catching of that exception is handled in the catch block. Okay, good. Now let's move on. So here this is an interesting example which is general again, and one good thing is that I will have a demo in today's lecture where you will see similar kind of structure, but that is more concrete example where you will see the real main method, the real method 1, method 2 and method 3. So let's see what is this figure saying. You have main method, you have method 1, method 2, and there's another method, method number 3, and we don't have the body of the method number 3. What we are saying is that an exception is being thrown by method number 3, which we need to handle somehow. And method 3 does not have the capability of handling the exception. So let's see what is going on here. In main method, you have a try and catch block. That means main method has some capability of handling exception. So in the try block, we have these two statements. The first statement is invoking method 1. And then there is some statement after method 1 invocation. In the catch block, we have the catch block for some exception 1 type. Exception 1 could be anything. It could be arithmetic exception, it could be an IO exception, okay, it could be index out of bound exception. But yes, there is some exception type which the main method can handle. And then in the catch block you can write those statements that you want to take, the statements that you want to write which will take care of exceptions. So process ex1 means that some statements which will process the exception which might occur in the try block here. Okay, then we have a statement 2 as well. So this is what makes our main body. Now since the main body is invoking method 1, let's try to understand what do we have in method 1. In method 1 again we have the try and catch block, but in the try block this method 1 in turn is invoking method 2, and after the invocation of method 2 we have a statement 3. Then there is a catch block similar to the way we had in main method, but this catch block is handling a different kind of exception, exception 2. Exception 2 is different from exception 1. And then in this catch block in in method 1 we have the statements which will process the exception 2, ex2 rather. Then we have statement number 4. So very similar to our main method, but it's handling different kind of exception. And main method was invoking method 1, method 1 is invoking method 2. So this is a kind of chain reaction kind of a thing. And after the catch block we have statement number 4. Now in the try block, method 1 is invoking method 2. Method 2 again has the similar kind of structure. It has a try and catch block. In the try block, method 2 is invoking method 3. Okay, and after the invocation of method 3, we have statement number 5. Then there's a catch block. The catch block in method 2 will handle exception of type exception 3, which is different from exception 2 and exception 1. So in this interesting scenario, if you look at the type of exceptions in the catch block, exception 1, exception 2 and exception 3, it seems to me that these different methods like main method, method 1 and method 2, they are capable of handling different kinds of exceptions. So for that reason, the class of the exception in catch of main method is exception 1. In the method 1 it is exception 2. In method 2 it's of type exception 3. Anyway, so in method 2 you invoke method 3, then after that there is statement number 5, and then we have a catch block which will process the exception 3, ex3 object, and then finally you have statement 6. And exception number and the method number 3 will raise an exception. So anyway, the exception which is being raised by method 3 is to be resolved by method 2 if method 2 can resolve. If not, then that will be passed back to method 1, and ultimately if method 1 can also not handle that, then that exception would come back to main method. So that's what we are trying to explain in this figure, and I believe the demo that I will be doing will help you a lot in understanding this concept. Well, so all this whatever you see in the top 3 boxes can be explained with the help of the call stack. So what is the call stack? So if you remember, if you could recollect the discussion on methods, so in one of the lecture on methods I gave you this idea about call stack. So whenever you have method invocation, then the call stack is used. So when you run this program, then the program execution starts from the main method. So main method will start running, and whatever temporary variables you have, or local variables I should be calling, for main method they are pushed onto the stack when main method invokes method 1. So activation record, as far as I can remember, is created for each method, and that activation record is pushed onto the stack. So here that's this region that you're looking at is reserved for the activation record for main method. So when main method invokes method 1, then we create another activation record for method 1, which is pushed on top of the stack. So on top of stack we already had the activation record for main method. Then now on top of that we have method 1. Method 1 is invoking method 2. So again you need to create another activation record for method 2 and put that on top of the stack, and then comes method 3. Right? So in this figure we are kind of giving this idea, like even in exception, when you have method invocation, we will have the usage of the call stack. Alright, so as you invoke methods, then the activation record of the executing method is put on the stack, and the execution starts for the next method. And how this is handled in exception, for that please wait for the demo and more details that you will see in next slides. Okay, so now you might wonder, as I was saying, that if the exception which is being raised by method 3 can be handled by method 2, then that's a very good situation, right? Then after handling the exception raised by method 3, the execution will start normally from here, statement number 6, and then you come back to the try block of method 1, then statement number 3, you skip the cache, statement number 4. So if the exception which is raised by method 3 is handled by method 2, very good. If not, then the exception will be passed on to method 1 to handle. If method 1 can do it, good. If not, then that exception passes back to main method. And if main method can address the exception which was raised by method 3, which could not be resolved by either method number 1 and method number 2, then that's a good news, because ultimately main method will resolve that. Unfortunately, if the exception is such that if you have an extreme situation where the exception raised by method 3 is not addressed by any of these methods, like method 2, method 1 and main method, then JVM will ultimately resolve that exception. So that's what we have here. Every exception must be caught. Uncaught exceptions will eventually propagate all the way back to the JVM, and then the JVM will terminate the program. So before learning about exceptions, so now we have learned about exceptions, and we are trying to address most of the exceptions that might arise in our program. Before that, when we did not know anything about exceptions, there were some exceptions, and those exceptions were caught by JVM. We were not catching it because we did not know about exceptions that time. Right? So if you don't handle your exceptions, then ultimately JVM will handle the exception and will terminate your program. And JVM prints something like this, which we call stack trace. So this kind of the message from Java you might have seen in your program, just like this, or maybe similar to that, which is usually in red color. So that signifies that JVM is handling exceptions. JVM is handling unhandled exceptions. Unhandled means what user could not, or what the programmer could not handle, is being addressed by JVM. Okay, good. Now let's look at try and catch, because this is very important component of exception handling in Java. So what do we have in a try and catch block? We already have done some demo, but let's look at some details as well. A try catch block is used to wrap your code that may generate an exception. Okay, and if the wrapped code does not generate any exception, then the catch block is completely ignored. So these are a few things that you really need to understand. If the wrapped code does not generate any exception, then the catch block is completely ignored. So the purpose of the catch block is to address any exception which might occur in the try block. So if in the try block you did not come across any exception, then the catch block would be completely ignored. So this is an important thing that you need to keep in mind. Catch block only executes if there is some exception in the try block. Okay, so that's what we mean by this bullet point here. And if an exception occurs, then the try block immediately ends. Alright, so if in the try block you have some statement 1, statement 2, statement number 3, and your exception has happened in statement number 1, then statement number 2 and statement number 3 will be skipped. Okay, so there is an emergency which has occurred in statement number 1. Emergency means an exception. So an exception, if it occurs, it will terminate the try block completely, and it will the control will transfer to the catch block, and the execution shifts to the catch block. Okay, and now the catch block has code to recover from the exception. Alright, and when the catch block finishes, then the execution continues after the catch block. Alright, but we never go back to the try block. Okay, so the example that I was telling you about a try block, like if I have 3 statements in the try block, statement 1, statement 2, statement 3, and the exception happened in the statement number 1. Then that exception will take us to the catch block. In the catch block we will resolve the situation, and after that the execution will start after the the statement that we have after the catch block. It will never come back to the statement number 2 and statement number 3 of the try block. So hopefully we will have some examples in which you will see this thing happening. Alright, so when the catch block finishes, execution continues after that block. We don't resume the execution in the try block. So these are few things you really need to understand about exception handling in Java. So here again we have some general structure of the try and catch block. So in the try you have some statements. Alright, execution begins here and continues until the end of the block is reached or an exception occurs. Right, and if an exception has occurred, then only catch block is executed. Right, exception object declaration, and this catch block is executed only when you have some exceptions. Alright, and after handling the exception, your execution will start from here. And if there is no exception, then this whole block, this whole catch block is ignored and the execution will start from after the catch block. Excuse me. Okay, now these are the same details, right, which are very important. So please pay attention to these things. Make sure that you understand all these points. If an exception occurs, the rest of the case and the code in the try block is ignored, which we have already seen in the previous bullets as well, but this is important, so no problem. Let's look at that one more time. If an exception occurs, the rest of the code in the try block is ignored. Execution resumes after the catch block. To make sure that statements are executed regardless of an exception, we use a finally block, right? So there's another thing coming in, which is finally. Till now we were only looking at try and catch, but there's another thing which is called finally block. So you'll have try block, catch block, and finally block. So what do we have in finally block? So if you have some statements that you want to run irrespective of exceptions, then what you should do, you should write that code in a finally block. So that's what we have here. To make sure that the statements are executed regardless of an exception, we use a finally block. Now code in the final block is always executed after the try or catch block completes. So this try, catch, and finally, all these things I have in my interesting demo that I'm telling you about. So we will look at that and I'll explain this thing in detail once we get to that demo. But if you write something in the finally block, then that will be executed irrespective of the fact whether you have exceptions or not. Right? So code in the finally block is always executed after the try or catch block completes. Now this means returning back to the main method. So this can also happen. Okay, this is an extreme case, but if you want to return back to the method where the exception occur, then that invocation you can put in your finally block. So let's look at the general structure of try, catch, and finally. So try and catch we have already seen. After try and catch you can write your finally block, and whatever code you're writing in finally will always run. Okay, so let's understand the whole structure. Execution will start in try block. Execution always starts here in the try block. Now if you have an exception on some statement, right, if you have, say, let me write that, if I have statement 1, I'm putting semicolon here, assume that that's line number 1, then you have statement 2. I'm not using indentation because I don't have space for that reason. Statement 3. If these were 3 statements and there was no exception here, but I had an exception here, exception on statement number 2. So if you have exception on statement number 2, then the statement number 3 will not run. Why? Because you have an exception right here, so this exception will take you to the catch block. Alright, and then the catch execution will happen, and even after resolving the exception, we never return back to never return back to statement. Why? Because the exception happened in statement number 2, which needed the attention by the catch. Okay, so that's what we have. But whatever you write in finally will always execute, right? So what can happen is, and if you have statement number 3 right here, then it will always execute. So whatever code you write in finally clause will always execute, right? So if you have an exception, then because of that exception in the try block, you may have to come out of the try block and handle that exception. And if there's no exception in the try block, your catch block would be totally ignored. So the execution of the catch only depends on the presence of some exception in the try block. So the execution of catch is conditional on try block. If you have some exception in the try block, then only the catch block will be executed. And it depends on the statement. If everything is fine, then only all the statements in the try block will be executed. If there is an exception in any statement of the try block, then the execution passes from there to the catch block. Okay, but in all the circumstances, whether you have an exception or you don't have an exception, whatever you have written in the finally block will always run. So that's something you need to keep in mind. Do more examples, you'll learn about that better. It's not difficult. You need to write some program and check it out yourself. I think the demo that I have will certainly help. Okay, so now there's an interesting thing which is about the catch blocks. Interestingly, one try block can be followed by several catch blocks. So I will do a demo on this. A try block can be followed by several catch blocks. Okay, and usually when you're writing different catch blocks, then each catch block will have the capability of addressing one kind of exception. So the point is, why will you write different catch blocks? Well, we will write different catch blocks for different kind of exceptions. So you might write one catch block for IO exception, then you can write the next catch block for arithmetic exception, probably the third one for maybe array index out of bounds. So you can write multiple catch blocks for one try block. Now each catch block that you write should be specialized in different type of exception. Then only it will make more sense. Example, you might write two different catch, one for IO exception, another one for arithmetic exception. Now execution, how will this execution work out when you have multiple catch blocks? Execution passes to the first catch block that advertises the ability to handle the exception. So for that reason, the catch block must be ordered from the most specific to the least specific. That means you should have subclasses first, followed by superclasses. Okay, and this ordering is very important when you have the parent class and child class involved, when you have subclass and superclass involved. Otherwise it will be meaningless, and I'll show you with an example that the compiler might give you an error that you are not using the proper ordering of the catch block. So ordering of the catch block is very important, and it should be most specific. That means the subclass first, followed by the superclass. It should not be superclass first and then the subclasses next. As an example, This is a good ordering where you can have a try block, and we have two catch 1 and catch 2. In the first catch block, it is has been written for an exception type file not found exception. Now this file not found exception is a subclass of IO exception, right? So this is perfectly fine. You should first put a catch block for the subclass, which is file not found exception, followed by the catch block for more general or superclass exception type like IO exception. So this is what we want. This is a good ordering. You're keeping this condition, which is more specific to least specific or less specific. More specific is the file not found exception, okay, and less specific or its parent class is IO exception. So this is the ordering that we want to keep while we have multiple catch blocks. What would be a bad ordering? If you flip that order. If you flip this order, then that will be a bad ordering. Like try, catch, IO exception I, and then IO exception is the less specific one, that's the parent. We have this kind of relationship if you're looking at inheritance. So let me make that blocks. This is one class, and then file not found exception, that is the subclass. Okay, so this ordering which we use in inheritance is not the correct ordering in exception. So we should avoid this. We want something like this, more specific followed by less specific. All right. So yeah, this is what we will get in the compiler error. It will say that it's never executed. So what I should do, let me do a few more slides and then I'll take you to the demo. Now passing the buck, what does it mean? A method that does not handle its own exception should throw the exception back to the invoking method. So if a method does not have the try and catch in itself, then it should if a method does not have a try and catch, then that means this method is not capable of handling its exception. So in that case, it should throw the exception to the invoking method or the calling method. Okay, so here if you go back to this diagram here, then method number 3, we do not have the body of method number 3, but seems to me that the method number 3 does not have a try and catch. So that's the reason some exception is happening in method number 3, and that is being passed, that is being thrown to method 2 to handle. And method 2 has try and catch. Now if the exception is of type exception 3, then method 2 will be able to handle it. If not, then that will propagate back to method 1. And if the exception which was raised in the method 3 is of type exception 2, then method 1 can handle that exception. If not, then it propagates further back to main method. Main method can handle exception 1 type of exception. So if the exception raised by method 3 is of type exception 1, that main method will handle it. Otherwise, it comes back to the JVM to handle, and ultimately JVM will handle it. So this is what we mean by passing the buck. Passing the buck. A method does not have to handle its own exception. It can throw the exception to the calling method instead. Okay, and if the method is such that it will be passing back the that it will be throwing the exception, then we need to declare that method with this kind of extension. We'll have to say that this is, we have already learned about it, right? This is the access modifier, which says that the method foo is public. Void means it is not returning anything. Nothing in the parenthesis means that it does not need any arguments. So this much we have already learned. This is something we learned when we were learning about, when we were doing methods. it is about how do we declare a method in general. But now in the method header we need to add these two things as well, which says that this method throws an exception. So you should say that this method throws, and then you need to give the type of the exception. So it seems like this method that we have, which is called foo, will or might raise an IO exception. Okay, so we need to modify the definition of this method by incorporating this fact that this method might throw an exception, and the kind of exception should be explained with the help of throws and the type of the exception class. Now, okay, so that's about a method which cannot handle its own exception. A client needs a try and catch. Client means the method which is invoking foo. That will be the client method. Client is method and that invokes foo. Alright, so the client in this slide's context, right? Client in this example for this method foo. So the client would be a method that will invoke foo, needs to invoke that in a try and catch structure so that it can handle the exception. It should be able to handle the IO exception, because that's the kind of exception foo will raise. A method may throw multiple exception types. So here you can have throws IO exception, then you can also have some other kind of exception. So a method can throw multiple exceptions. So we don't have a limit that foo can only throw IO exception. It can throw arithmetic exception as well. So if your method can throw multiple exceptions, so you can declare your method in such a way. You will say throws IO exception, comma, arithmetic exception, maybe some other exceptions. If you feel or if you think that your method can raise multiple exceptions, then you need to declare it accordingly. Use keyword throws, and after that put all the class types of the exceptions which this method might raise. Alright, so how do we throw an exception? Throwing means you need to check whether we have exception condition or not. So if you remember in my previous video lecture when we were doing arithmetic exception which involved the division by 0, so how did we do that? We checked this condition. We checked that if denominator is equal to 0, then what you can do? Well, then you can say new arithmetic exception. Arithmetic exception. Alright, now it is up to you. You can, in the constructor, you can say divide by 0. Alright, or you can write it in your, you can write it like divide by 0, or just a symbol for division followed by 0. So what you did here, you created an object of type arithmetic exception. You created that with the help of the keyword new, just the way we create any other object, and you need to pass that with the help of throw. Alright, so this throw keyword is important. Just the way throws is different. Like what throws does, throws defines a method header with the information. I should say that throws adds the information in the method header which conveys the information that the method might raise exception. So throws is different from throw. What throw will do? Throw will pass on the exception to the calling method. Okay, so how do you throw the exception? How do you pass on the exception? With the help of the keyword throw. So let's read it. When the program detects an error, like the way we were doing for divide by 0, the program can create an instance of the appropriate exception, which is arithmetic exception, and you need to pass on a string there. And throw it. Throw it means use this keyword throw. This is known as throwing an exception. Alright, So the example that we have here is either you can write everything in one statement the way I have done, and the way you see right here in just one statement. First create the exception and then throw that in one line itself. Or you can split that in multiple lines. You can say the exception ex is equal to new exception, and then you throw exception. If you want me to do that, I can write this same statement like this. I can say arithmetic exception, there's no space here, exception AE. Alright, so what is AE? A is the arithmetic exception. Well, I think I'm splitting that in 3 lines, but that is okay. Then you can say arithmetic exception AE is equal to new arithmetic exception and now you will write divide by 0. Okay, and then in the third line you will say throw AE arithmetic exception. So all these 3 things, all these 3 statements are equivalent to this statement right here. The important thing is that you should know what is throwing an exception and how to throw an exception. There are multiple ways of doing it. You can do that in one single line the way we have here, or you might split that in multiple lines. So as an example, right, assume that you have written an exception, you have modified your circle program with that information that if the user is specifying the radius which is less than 0, then it should raise an exception, because a circle with the radius less than 0 is meaningless. So you might create an exception for that. So we can incorporate that exception thing in the set radius method. So what do we have in this set radius method? Let's look at that. So you have public void set radius. Okay, so if you're setting a radius to some value, then you don't need to return anything. So that's the reason it is void. You're setting a radius to new value, you don't need to return anything. So for that reason it is void. Public is fine. So this is a setter method. So setter method should be public. So public void set radius, and we do need an argument which is new radius. So your radius should be updated to this value, new radius. So its argument is double new radius. Perfectly fine. Now let's see what else do we need to add here. We need to convey this information that this set radius method that we have now is capable of throwing an exception. So what exception it is throwing? It is throwing an exception called illegal argument exception. Alright, so this is also a kind of exception. So the method set radius that we will write now, which is the modification of previous set radius, has the capability of throwing an exception. So that we need to explain by writing throws. We need to write throws in the method header, and we'll say throws illegal argument exception. And in the body of this set radius method, we will check if the radius is greater than or equal to 0, we are fine. We will update the radius to the new radius. Otherwise, if the radius is not greater than or equal to 0, now is the time when we need to create an exception object and throw that back to the method that is invoking the set radius method. So how do we do that? We say throw new illegal argument exception, and in the parenthesis we are putting the statement that says that radius cannot be negative. Okay, yeah, so this is an interesting example, right? So I'll encourage you to have a look at it and make sure that you understand it. And if you have already written circle class, why not extend that circle class and change your set radius method like this? Alright, so I think I can take the next slide as well, because that next slide is dependent on the slide number 29 that we were looking at. So what will happen now? You will have to, you can create another class, right? So this new class is circle with exception, because previous circle class that we wrote was very simple and we were learning about object and classes using that circle class. Now since we are learning exception, let's create another circle class and we'll call that circle with exception. So our new class is public class circle with exception, starts from here, ends right here. Good. Now this class has a data member radius, which is private and double, just the way we had in the simple circle class. We have a static method which will count how many objects we have, initialize that to 0. Now we have written a constructor for this class, so its name should be the same. So we'll say public circle with exception. This is a no arg constructor, and therefore we are calling this 1.0. That means we are invoking another constructor. I'm not sure if you remember these things, but you should look at it like what will happen if you invoke a method like this and with the parents. It means that you are invoking the second constructor, the constructor that is defined with a double value. Okay, so now the second constructor that you have written is special constructor. Why special? Because look at this declaration, public circle with exception, just similar to the first one, but this is an arg constructor, so you passed on an argument which is double new radius. And look at this part, this is important. What is it doing? This additional information which you have, you're saying throws illegal argument exception. It means that this constructor that you have, where you're passing on the new radius, it might raise an exception if the radius happens to be negative. That information should be conveyed in the header of this constructor, and that's precisely what we have. We are saying that the second constructor, which is the arg constructor, will throw an illegal argument exception. It throws illegal argument exception. And what do we do inside this method? We are invoking set radius and incrementing the number of objects. What is this set radius method doing? Set radius method is the one that we saw in the previous slide. Okay, so set radius method is also a method that can throw illegal argument exception. That will happen if the radius is negative. If the radius is negative, then it will throw the illegal argument exception, and for that reason, because of the call to the set radius method in the second constructor, we can have an exception here, right? And that exception needs to be handled in the invoking method. So we haven't seen invoking method yet. Alright, then the other two methods are just simple as we had. So you have a static method to get number of objects. Number of objects you are updating in the constructor. If you create a new object, you need to update this number of objects, because that is capturing how many objects you created of the type circle with exception. This is a different class, circle with exception. Now you can write the find area as well. This is interesting. Now when you look at main method here, then in the main method is the method which will invoke the constructor, right? So in the main method, you're invoking the constructor with the value 5 as the radius, invoking the constructor to create the object C2 of type circle with exception class, radius being -5, and the third time you're doing that with radius as 10. Now these are the places where you can have exception. Why? Because you're invoking constructor, and go back, if you invoke a constructor, then the constructor can raise an illegal argument exception. Alright, so because of the fact that the constructor in this example can raise an exception, we need to put all these invocation of constructors in the try block. So all these calls, like wherever you created an instance of the circle with exception class, you put that in the try block, and followed by try block you have written a catch block, and this catch block will handle this exception, which is illegal argument exception. Alright, so you have a catch block which will handle any exception if that happens in these two statements for creating C1, C2 and C3. And you can see that we have problem right here because -5 is negative, which will raise the exception illegal argument exception. Then you want to print out how many objects have been created, and if you try it out, it should be 1 because we succeeded in creating only one circle with the radius 5. After that, we had an exception in line here, and this exception took us to the catch block, and after catch block we will come here. We don't go back to the statement number 3 here. We don't go back here. Alright, so that's the reason the output should show number of objects created as 1 only. Alright, so what I will do now, let me do some demo, and I will start with delete this thing here. I'll do the demo involving multiple exceptions. So multiple exception means we will have multiple catch blocks, and let's see that interesting thing. So I should say public class multiple exceptions. Since the name of my file is multipleexceptions.java, so I created my class with the same name, multiple exceptions. So here I'm writing a very simple program. I need main method, void main, and in the main method we have string. This is what we need. Alright, so what should I do? Numerator and denominator, simple arithmetic expression kind of a thing. Let's try to do that. And I need a try and catch block. Try followed by catch, and I will be writing multiple catch, so 2 catch. In the try block, let me do very simple stuff, which is system.out.println, and here I should do now numerator divided by denominator. I should initialize numerator with some value. Let me put numerator as 10, denominator as 5. So there is a try block which will do this computation, numerator divided by denominator, and after that I want to write couple of catch blocks. You can write even more. Okay, so initially I'll go with the proper way. I'll follow the way that we should do. So here first catch that if I will be writing will be more specific one, arithmetic exception. Arithmetic exception. Now what should I say? System dot out dot println, I would say from arithmetic exception plus AE dot get message. So getMessage is a method in the exception class which will return the message that an exception generates. Okay, so that's my first catch block. I can write another catch block. I will keep that as exception E, and I will use this same statement with some modification, e.getMessage, and this is from exception. So the reason why I'm adding these to the string like from arithmetic exception in the first catch block and from exception in the second catch block is to just make sure that which catch block is active. Is it the arithmetic exception catch block or is it the exception one? So I'll save this thing and let me run this program. Yes, we say Java C multiple exceptions dot Java. Good, so no errors. So answer being 2 is what we were expecting. Let me change the font size a little bit. Fonts 24 is what I would prefer. Cool, so this looks a lot better. Great. Now no exception. I will introduce some exception. If you divide by 0, then that should result in an exception. So I will compile. Then now let's run it. Alright, so from here you can see that I'm getting this exception handler from the first catch block which says arithmetic exception. Right, so that's what I have written here, from arithmetic exception. That means from the first catch block. Let's run this one more time. Okay, so yeah, this is perfectly fine, and that's what we learned. We learned that we learned it from our lecture slides, that if you have multiple catch blocks and these catch blocks are in some kind of hierarchy, inheritance hierarchy, then we should order it in from more specific to less specific. So arithmetic exception is more specific. This is the child class of exception class, so this is perfectly fine. But if you want to flip this order, then you will have problem. What did I do now? I'm changing the order. I'm making less specific first and then the more specific later. So if you change this order, because exception now is the parent class of arithmetic exception, then you will have issues, and you should not be doing it. Let's compile it. Right, so yeah, compiler in itself is getting this message that arithmetic exception has already been caught. Where is that being caught? This error is being caught by the more general version, which is the exception. Alright, so please keep it in mind. If you have multiple catch blocks and in these catch blocks you do have some inheritance hierarchy, then make sure that the subclasses are coming prior to the parent class. Okay, so that was one demo, and then I have another demo right here. Well, so this is what I was telling you about. Here we have an interesting scenario. Let me pull the corresponding lecture slide. Lecture slide right here. Yeah, this one. So here in our lecture slides we have more general example involving main method, method 1, method 2 and method 3. So here in the program I'm calling that quiz because I use this example in my class quiz. So here in this class quiz, in the quiz exception class, There's this one method which is main method. Then you have method 1 followed by method 2, and then we have method 3. So there are 3 methods. There are in fact 4 methods: the main method, method 1, method 2, and method 3. And method 3 is the one which is raising an exception. So you might ask me this question, that why do you say that method 3 is raising an exception? Look at it, like what are we doing here on the line number 43? Z is equal to 1 by 0. So that means you're dividing by 0. If you divide by 0, that means it's an arithmetic exception. So method 3 is raising an arithmetic exception. Fine. So we know about this method, which is very simple. Method 3 that raises an exception. And here we don't have any try and catch. So what will happen? This exception would be passed back to the method which is invoking method 3. Good. So let's try to understand the whole program one by one. We will start with main method. Let me highlight this thing so that you can focus on just main method. Here you have a try block and a catch block, and finally as well. So with this example, you will have a very good understanding of try, catch, and finally, all these 3 components of exception handling. Now, what are we doing in this main method? We are invoking method number 1. And this invocation of the method number 1 is put in the try block. So we are expecting some exception from method 1. That's the reason we are putting this invocation of method 1 in the try block. And then there is a catch block, and the catch block is capable of handling exception type, exception object, right? So this is the most general exception class, I'll say. So the catch block of main method will handle any exception of type exception class. Therefore, we have the corresponding println method, which will say that we were able to catch the exception in the main method. Then you have a finally block in which you have written a statement that says statement 2.0, and the last statement in this main method prints out statement 2. So these two are different. Statement 2.0 and statement 2. These are 2 different statements. Statement 2.0 is the statement which we have in the finally block of the try, catch, and finally in main method. Good. So the very first thing that will happen in the main method is the invocation of method 1 on line number 4 in the try block. Let's see what do we have in method 1. So method 1 is from here to here. Again, I will highlight that. Interestingly, method 2 is doing the same thing as method 1, but method 1 is invoking another method, which is method 2. And method 1 is also expecting some exception from method 2. That's the reason method 2 invocation on the line number 17 has been put in the try block. This is followed by another statement which will print statement 3. Then you have a catch block in method 1, and if you look at the type of exception that method 1 is ready to handle, then it is arithmetic exception. Okay, in main method, the type of exception was exception class, the parent class of arithmetic exception. But here it is arithmetic exception. So method 1 has the capability of handling arithmetic exception. Then we have this println method that will print arithmetic exception method 1. So this will give us an idea that we are able to handle the exception in method 1. So that's the reason this println has been written that way. The type of exception, which is arithmetic exception, and it has been caught in method 1. Good. So that was our try and catch. What do we have in finally? In the finally block, there's this statement 4.0, and the last statement in the method 1 is statement 4. Now let's go to method 2, which will be invoked by method 1 in the try block. Similar to main method and method 1, the structure of method 2 also has try, catch, and finally. In the try block of method 2, we are invoking method number 3, method 3 here on line number 30, and after that we have this statement, statement 5, which will be printed out if our control reaches line number 31. And interestingly, the type of exception which method 2 will handle is index out of bound exception. That's the reason we have declared the catch block with EX as an object of type exception index out of bound exception. And in this catch block we have the corresponding a println method which will print index out of bounds, which is the type of exception, and it will also print method 2, signifying that this exception has been caught in method 2. Alright, and then similar to the method 1 and main method, we have a finally block as well, where we are printing the statement 6.0, and the last statement in method 2 is statement 6. Alright, okay, so if you look at the structure of main method, method 1 and method 2, they are very similar. The only thing which is changing is that they are handling different kind of exception and they are invoking different methods. And yeah, the statements that they are printing are different. Statement 1, statement 2, statement 1.0. Do we have statement 1.0? No, we don't have statement 1.0, but we do have statement 2 and 2.0. Now to the most important method, which is method 3, and I told you about method 3 earlier, that in the method 3 on the line number 43 we have the exception. Okay, so now let's try to understand and give some and make a guess about what would be the output if you run this program. Alright, so what I will do here, let me use this file to give you some idea about what we will expect as an output and why so. Alright, so when the program will run, when I run this program, it will start from the main method, and the line number 4 will invoke method 1. In the method 1, when you come, then in the method 1 you will go to the try block, and then the line number 17 will run, which will invoke method 2. In method 2 you come to the try block and method 2 will invoke method 3. And this method 3 now, when you invoke method 3, then on line number 42 you do not have any problem. But on line number 43 you have exception, which is arithmetic exception. So this arithmetic exception would be thrown to the method 2. Now method 2 has to handle the exception which are happening in method 3. Why? Because method 2 is the one that is invoking method 3, and method 3 does not have any try and catch, but method 2 has try and catch. So this arithmetic exception that you have here in method 3 would be thrown back to method 2, because method 2 is invoking method 3 right here, and because of the exception on line number 30, the execution will be passed on to the catch block. Okay, because method 3 is invoking an exception, method 30 the statement on line number 31 will not run. Instead, the control will be passed to the catch block, and in the catch block, this catch block that you have in method number 2 is capable of handling exception of the type index out of bounds, but the exception which method 3 is generating is arithmetic exception, so this catch will fail. Right, so method 2 is not capable of handling the exception which was raised in method 3. So that exception which was raised in method 3 will be passed on to the method which invoked method 2, that means method 1. Alright, so method 1 will try to handle the exception which is raised in method 3. But we should think about finally, and I said that whatever you write in the finally block will always run irrespective of the rest of the things, whether the exception was raised or not. So because of this finally block, we should be able to see the output as statement 6.0. So that's the first line which you will see in the output. Why? Because that's the first finally block which a program will hit. Alright, if it was not in finally block, it will be skipped. So the statement on line number 39 will be skipped. Why? Because there is an exception which was not handled in method number 2. So that exception passes back to method 1. Okay. So in method 1, since the exception from method 2 has not been resolved, statement number 18 will not run. Why? Because we have an exception which is not resolved, and that exception was generated in method number 3, but method 2 could not address it, so method 1 has the responsibility to address the exception, and the type of exception was arithmetic exception. Luckily, the catch that we have written for method 1 is of type arithmetic exception. Alright, and this arithmetic exception type is matching the exception which occurred in method 3, so we will be able to handle this exception in method 1. Therefore this thing will work. What is this? You will get the second line of output as this thing. What is it? Arithmetic exception method 1. Method 1 will be successful in handling exception which was raised in method 3 because its catch block is capable of handling arithmetic exception. Alright, and although we are successful in handling the exception on line number 20, the control will never go back to line number 18. Why? Because when we had an exception on line number 17, the control came to catch, and after catch the control never goes back to the try block. But whatever you have in the finally always runs. Okay, so after the catch block, the next output that you see would be what you have in the finally block. Alright, and since the exception has been handled by method 1, so the life is back to normal. So the last statement of method 1 will be executed. Okay, and the control will be passed on to line number 26. And you see this line as well. Alright, so after the complete execution of method 1, the control comes back to line number 5, and since the exception has been resolved in method 1, everything is fine now, so the try block will work as usual, right? So there's no exception. For that reason, even the statement on line number 5 will work, and the result would be statement 1 being printed out. Now because there's no exception in the try block, so the catch block will be totally skipped. Catch is only executed when there is an exception in the try block. We don't have any exception. Whatever exception was coming from method number 3 has been resolved in method 1. Okay, so after that, once the control returns from method 1, the normal execution of the statement on line number 5 will take place, which will print statement 1. Okay, catch will be totally skipped. Finally, is always run. So you should see this as well as the output. And then finally, the last statement in the main method is statement 2. So you should see that thing as well as in your output. Alright, So I hope whatever I have written here is correct, and so for that reason I should run this program and verify the result. Okay, so I need to pull it up a little bit and let's tally the results. Statement 6.0 is the first one. That was the statement in the finally block of method 2. Then you have arithmetic exception method 1, because method 1 was successful in handling the exception. After that you have statement 4.0, which was, I believe, the final statement 4.0, right? So the statement 4.0 that you see here is in the finally block of method 1. After that you come out of the finally block because method 1 has resolved the exception. So even the last statement after the finally block in the method 1 will run, printing statement 4, right here. After that you come back to method number 1, sorry, main method, and main method everything is working fine, so you print statement 1. Alright, catch will be skipped because we don't have any exception. Whatever we had was resolved by method 1. Catch will be totally skipped, and you have finally, which is printing 2.0, and then the last statement of the main method, which is statement 2. Now what I will do, let me change the exception. Alright, so how can I change the exception? I will say int z is equal to x 5. Okay, so now this is something you need to think about, like where do we have exception? Do we have any or not? So answer to that is yes, we do have an exception here. I'm accessing an element out of the bound, right? So index out of bound exception has been raised right here. So what will happen? I will just run that and I'll leave it on you to figure out. If you people need this quiz, then let me know. I can share this source code so that you can run it on your machines and figure it out. Alright, so that is an exercise. I will just run that and I'll leave the rest for you to figure out. So what happened? Index out of bounds in method number 2 has been handled, and then you have these sequences, right? So please, that is an exercise for you people. Request me for this source code. I will be happy to share that with you, and you need to figure out like why are you getting the outputs in this order. Okay, so I have few more demo programs. Alright, so circle class we have already seen. Okay, so what I will do now, I will create an example with an exception that we will define. So till now we were using exceptions like arithmetic exception or index out of bound exceptions and arithmetic exceptions and the exceptions. So these are the exception classes which are defined in Java. What we are going to do now, we will create a custom exception. Exception means the class that I have here is new. I am defining that. So invalid radius exception is something that we will define now. It does not exist in Java. Okay, so how do we do that? Well, we will follow the normal thing that we have been doing in Java till now. So this new exception that you're defining, the custom exception, which we are calling as invalid radius exception, it should be a subclass of some class in exception. So what I'm doing, I'm making this invalid radius exception class as the subclass of exception. You can probably make it as the subclass of illegal argument exception. That is fine too, but I'm keeping it very simple. Alright, so what should we do in this class? So the very first thing which we need to do is to create a constructor. So the constructor would be invalid radius exception. Okay, and here let's define only one constructor with radius. Alright, and what do we do here? So how do we define this constructor? We will simply exploit the constructor that we already have in the exception class, and we should say that invalid radius value radius. So that completes our very simple exception that we are calling as invalid radius exception. Now we will write another class, circle exception, and in this class we have a data member radius, which is being correctly declared as private and double, and there is this one constructor which is no arg constructor, and this no arg constructor is initializing the radius to 1. Now let's create one more exception, one more constructor, exception, circle exception, and here I will pass on some radius value, but I want to make this constructor as one which will throw an exception. So that information I should convey by using throws. Invalid radius exception. Alright, so what is this invalid radius exception? I just defined that in the previous class. Okay, so now I'm telling this thing to the Java that the second constructor which I'm about to write, which is an arg1, it might throw invalid radius exception. So the constructor is defined as public circle exception. It will take the radius, which is a double value, and it will throw invalid radius exception in case the radius is negative. So how do we take care of that? Well, for that I'll do something like this. I'll say if radius is greater than or equal to 0, that means we don't have an exception, this dot radius is equal to radius. I hope that you remember what was this. If not, then please go back and refer to the previous lecture on classes and objects. Now in case you have an exception, then what should you do? Well, then you need to throw new invalid radius exception, and you pass on the radius as well. Why should you pass on the radius? Because look at this constructor, the only constructor which we have written for our custom exception that we are calling as, that I'm calling as invalid radius exception, it is accepting one argument which is of type double. Good, so I believe that we are almost done. What I need to do is I should put one tester class as well, but to save some time I will not create another tester class. In place of that, what I can do is I can write a main method. So public static void main. This main method will test the custom exception which we have written. String args. So what should I do here? Well, I should write one more method actually. Let me write a toString method. Public string toString, and return circle with radius Okay, fine. So now we have toString method as well. Now in this main method, which I'm using for the purpose of testing my exception, let me create two circle objects. Circle exception C1 is equal to new circle exception, and here I'm using no arg constructor. Let me raise few more. Circle 2, its radius is 2.0. Circle C3, 2.0. Wait a second, why are we getting this message? Alright, I got it. Okay, we will handle that, don't worry. That's an interesting thing. Circle C4, let's try minus 3.5, and this is 4.4. Now what we should do is, since this class that you have right here, its constructor has the capability of throwing an exception, so what we should do, we need to put all these things in a try block. Okay, and then I should write a catch, and the catch should be able to handle this exception ex, and here we can write ex dot get message. Alright, now we are complete. Let me add few system out thing, because I want to check, I want to see whether this thing, the circle was created or not. Alright, so what do I have in this main method? I have a try and catch. Now the question is, why should I create try and catch? I should create try and catch for the reason that the constructor that we have, which we'll be using, might raise an exception if the radius is invalid. Okay, because of the second constructor. For the default, for the no arg constructor, we don't need anything. I need to change these values: C2, C3, C4. Alright, yeah. I created C1 object with the no arg constructor for circle exception class. The second object, which is C2, and here I am passing on the radius as 2, which is an arg constructor. For C3 and C4 also I am passing on some values, so these are the invocation of constructor which has exception, and I am using the catch block properly to handle this exception which we have defined in the invalid radius exception class. Cool, so let's run this program. Okay, so now we will interpret our output. Output says that we have the circle with radius 1. What does that mean? Circle with radius 1 means that you invoked no arg constructor, which happened on line number 17 and 18. You created C1 as the circle exception class with the default radius, which we set up as 1 on line number 4. That's the reason you're getting the circle with radius 1.0. For the object that you created, C2, on line number 19 and 20, its radius was set as 2, and you got the corresponding toString invocation circle with radius 2.0. We are getting this thing from the toString method. Okay, now the interesting scenario is right here, which is the creation of the object C3, which we want to do with the radius as 3.5, minus 3.5. Now this negative value of minus 3.5 will result in an exception right here. Okay, the radius, if the radius is negative, which is minus 3.1 here, then that will result in throwing of an exception. Alright, and that exception is being caught here in the catch block. Alright, and what you see is this message which says that invalid radius value minus 3.5. Okay, now interesting thing is that since we encountered an exception on line number 21, so none of the statements on line number 22, 23 or 24 got executed. You got exception on line number 21, which resulted in the control being transferred to the catch block, and after that you are never allowed to return back to the remaining statements of the try block. Okay, so perfectly in agreement with what we have learned. But honestly, although I tried my best to make this example very simple, I still believe that you may have difficulty if you don't try it yourself. Right? So please try it yourself. Read this, go over my video lecture, read the corresponding material on the textbook or my lecture slides, and then try to do something similar to what we are doing here and see for yourself that this works. Alright, and it's very interesting in fact. Fine, so I'm done with my demo on exception. So I'll take you back to my lecture slide and I'll go over the content that I just showed you in my last demo example. So here you can define your custom exception class as well. Let me use pen here. Okay, so you can define the custom exception. So that's what we did. So you can define exception class if the predefined classes are not sufficient for you. I will not read all these points because I don't like reading every point. Let's look at an example. So this example is very similar to what I did. Probably this is a little more complicated than what I have done, but it is more systematic. So let's look at that. So here you are defining an exception class which is called invalid radius exception. Okay, similar to my demo. So you will define public class invalid radius exception which extends the exception. That means it's a subclass of exception class. And right here you have a constructor very similar to the constructor that I had written, and that constructor you're calling the super. That means you're calling the constructor of exception class, right? So super means the parent class, which is your exception class. There's already a constructor there, so we are calling that with our own message which says that invalid radius, and then we also specify what radius value do we have which we are calling as invalid. Then if you want, you can initialize your radius parameter. I did not keep this in my example because I found this, I thought that we can write a very simple example, but if you want, you can declare one data member for this exception class also as radius. And if so what do? We also set the radius as the new value if you have this data member. If you don't have it, you don't need to keep that. Then there is a getter method if you just want to use it, but it may not be needed the way I did in my demo. Cool. So now we will make use of this exception which has been defined in the previous slide in a new class. So we call this as class circle with radius exception. Here we have the data member radius which is double and private, And in the constructor, so this is slightly different from what I did in my demo. It's a little more involved, but no problem. We'll try to understand that. This is a constructor, circle with radius exception, right? This name matches the name of the class. So this is a constructor in double new radius. Now we are not saying that this throws exception, right? So this is different from my example where I said that the constructor throws the custom address, which is invalid radius exception. Why? We are not writing here because this constructor in itself has try and catch block. Okay, so this constructor that we have written in on the lecture slide is self-sufficient to handle exception by using try and catch. So if the new radius that you want for your object is invalid, right, then what will happen? We will raise an exception. Okay, so let's try how are we initializing the radius. In the try block, the very first statement that we have is the call to set radius method. Let's look at set radius now. With the new radius value, assume that I have minus 1.5 as the new radius value, which I will anyway pass on. If I do something like this, if I say new circle with radius exception minus 1.5. If I do something like this, then for whatever value I have for new radius, I'll have to invoke set radius method. Now and this is something I'm doing in the try block. Let's pay attention to set radius now. This set radius method that we have, we are defining it as such that this method might raise an exception, which is invalid radius exception. So when will that happen? If your new radius, which is minus 1.5 in my case, is greater than or equal to 0, then we will set the radius, this radius, to new radius. Only if the radius is valid. If not, then we will throw an exception. We will create a new exception of the type invalid radius exception with the value of the radius, which is minus 1.5 in our case, right? And this exception that you're throwing here in the set radius would be caught in the constructor. Okay, so if this is an exception here, it will be caught here in the catch block of the constructor, and the constructor will print the stack trace. So either you can print the message as I've done in my demo, or you can invoke the print stack trace. So stack trace is more detailed information about the exception. So you can try print a stack trace, or you can do something like maybe ex.getMessage. Ex.getMessage would be more what I'll say concise than print stack trace, but in print stack trace you'll have more information about exception. Okay, so this is again a very interesting example which I would encourage you to follow and try your best to understand after looking at the demo that I had a few minutes back. Good. Alright, so now the last topic for this lecture is files, and in files we'll do text files. So why do we need files, right? So let's get it straight. A lot of times we want to store data permanently. Permanently means that we want the data so that it should stay in our computer even if we switch off the machine. So whatever you have in your RAM, which is random access memory, or we also call that dynamic memory, is deleted once you switch off the machine. Right? So a lot of times we want the information or the data to be stably stored, stable. What does that mean? We mean that it should be permanently stored. Permanently stored where? On your storage device. Storage device means your hard disk, to be practical. I'm just giving you one example. So for those kind of things, if you have to write a program where you want the output of your program to be stored somewhere permanently, then you'll have to use files, right? And a lot of cases it gets very easy when you're handling very large data, if that data comes in files. Okay, because on the storage device you'll have more space available compared to your random access memory or your main memory. So what we have to learn now, we have to look at the facility that is available in Java for us when we want to work with files. Okay, and a lot of programs that you come across in your day-to-day life, they deal with files. Like your word processor is an example where you deal with files. Similarly, the games, and so you might find even more examples. Alright, so the good news with Java is that dealing with files is very simple. What you need to know is you have to learn about some classes. Alright, so I can write about those classes here. They are not many. So one of the class is file class. Then you will need to use scanner class, which you already know, but we will use scanner slightly differently. And then you will need some classes like print writer, and you will know you'll need another class called file writer. And using these four classes, you will be able to read from a file, write to a file. Okay, so we will learn about these four classes in the next few slides. Alright, so what we will learn, first we will learn to read a file, and then I'll tell you how to write a file. So it will be mostly demo kind of a lecture, but let's look at some important slides. So the file class that you have, we will use file class to define file object. Okay, and how do we do that? Just similar to the way we have been using classes till now. So if you have to open a file for reading, then or even for writing, then what you should be doing, you need to create the file object. What is foo here? Foo is a file object. And how do you define file object? For file object you need this file class. Alright, so you'll have the name of the file, name of the class, which is file, then the object, class object, which is foo here, is equal to new file, you call the file constructor, and inside the constructor you give the name of the file. So this file could be an input file or the output file. So if your program is based on reading content of a file, then that should be your input file, and it depends on what name of the input file you have. It depends on the name of the file actually. So we are calling that as input.txt. It could be any other name as well, and we are looking at only text files. Okay, now here the name of the file that you have could be just the name of the file like this, or it may have the full path. So full path would be something like that: CSE114 and input.txt. So right here I have the full path, right? So you can either specify full path or you can just specify the file name. So if you're working in the same directory where your input file is, then you need to just specify the name of the file. But if your file is in a different directory, then you will have to specify full path of the file, which will involve specifying the drive and the folder, and inside the folder the specific file which you want to read. So for these files, I would encourage you to make sure that your file is in the same directory in which you are writing your program, or same folder in which you are writing your program. If not, then you will have to do this extra work. You'll have to locate the file. You'll have to find out where exactly your file is located. Then only this will be able to access that file for reading. Alright, so let me take you to the demo, because I believe the best way to teach file is using a demo. Okay, so here I will use Eclipse. Sorry, not Eclipse. This is my Sublime. The reason why I use Sublime is that it keeps the life a lot simpler. Read file. Readfile.java is already there, and I will write my program in read file class. So let me make this font a little bigger. Public class read file, and here in the read file I will write public main method, public static void main and string args. Okay, right, so what do I need? I need to use file input, let me call that f. Okay, usually we use f as the name of the file object. New file, and name of the file is input.txt. Let me show you where exactly my input file is. So this is my folder, and the read file class that I'm writing is in readfile.java. So readfile.java is in the same folder as is my there should be input.txt. okay, so I don't have input.txt. I will have to create input.txt first. So new file, let me create input.txt. I want to put the double values. You can try any other data type as well, it will work perfectly fine. Few things will change, please. I'll tell you what will change. 100 minus 300 76 99 1256 point, okay, 122 789. So I put some arbitrary values in there in a file, and I'm calling that input.txt. Alright, so this is my input.txt file which I created, and I'll write a program which will read the contents of this file. So input.txt, and the file and the program that I'm writing here to read the file will read the contents from my input.txt file. And just to show you, input.txt and the read file, these two are in the same directory, so it will make my life a lot easier. Otherwise I'll have to specify the path, like where exactly my file is. So I'm not specifying path because my program is in the same directory where the file is. Cool. Now what we do, we need a scanner class. Scanner read is equal to new scanner. So till now we were using system.in, because system.in means we are reading from keyboard, but now I don't want to read from keyboard. I want to read from the file input.txt. So when you have to read from a file like input.txt, then what you should do first you need to create a file object f, right? So how do you do that? You'll say file f is equal to new file input.txt. So that will create a file object for input.txt input file, And then if you have to use scanner class, which we do, to read the content of file input.txt, then in the scanner constructor will have to pass this file object f. Alright, and then after that what we do, we will make use of some methods which are there in scanner class. While read dot has next will return true as long as there are some contents in the file which are to be read. So what I'll do is system dot out dot println. What do we print? Read dot next double. Why next double? Because I know that the content in my file are double values. If these were integers, I'll say next int. If these were strings, I'll say next or next line. Alright, so what did I write here? After creating the scanner object read, to read from my file input.txt, I can use this read object to check whether I have the the contents in the file which are still to be read or not by using read.hasNext. So as long as there are elements in the input file which I still need to read, it will return true. So as long as I have elements to read from the file, the while loop would be correct and I'll be able to print the content. And how do I print the content? I'll use read.nextDouble. Why? Because the values in the file are double values. Okay, now interestingly, this is what we need, but it's not complete yet. Why is it not complete? I'll add few things and then the remaining things I'll fix by giving you some demo with some bugs. I'll get some compiler error. I want to show those errors so that you know why these errors are coming and how to fix these errors. Import, let's import few things, right? Import java.util.scanner. We know where exactly the scanner is, so this should not be a problem. You'll import scanner from java.util. You also need to import Java. You will have to import file class. Okay, this file class. So how do you import that? You'll see java.io.file. So import is fine, but there's another issue here which I'll show after compiling. So let's compile Java read file.java. Right, so we have a compiler error somewhere. Okay, yes, after the import you should have a semicolon. Let's run this. Good. Yeah, this is the important thing that I wanted to tell you. So for that reason, I did not complete the program and compiled it. Now for files, whenever you're dealing with files, then you need to handle the exceptions. So if you look at this error, then the error is saying the same thing. You did not handle the file not found exception. So IO exceptions that we have, so file not found exception belongs to the IO exception. IO exceptions, let me take you to the lecture slides, right? A few slides back when we were doing exceptions. Okay, right here. IO exception. So IO exception is the wait a second. Runtime exceptions and errors are unchecked exceptions, whereas all the other exceptions are checked exceptions. So checked exception. So IO exception is a checked exception. That means that for the program that you're writing which deals with IO means input and output. So this file not found exception that we are getting here, file not found exception, this is a subclass of IO exception. So we need to handle these exceptions. So this is a checked exception. If you don't use this, if you don't address this exception, then you'll get the compiler error, right? So unchecked exceptions. Alright, so whenever you are writing program on files, make sure that you are checking the exceptions. If not, then compiler will raise an issue like this. So we need to look at file not found exception. So how should I do that? Well, let's write a try and catch. Try and then catch. What should be the type of the catch? Well, compiler helped us saying that we should have file not found exception. EX. Alright, and whatever we were doing here, it should be copied in the try block. Yeah, good now. And I need to write something in the catch block. I'll say system dot out dot println and shall use ex dot get message. Okay, good. I think we are good to go. Yeah, you need to import this as well. Import java.io dot file not found exception. Let's see. Now we will compile this file, catch and try. Try without a catch. Wait a second. I think you have try, and then after try we do have a catch. Try and then a catch. File not found exception EX. Looks good to me. Let's see. File not found exception. File not found exception. Okay. Reached end of the file while passing 3 errors. Try. Line number 6 is try. Public static void main. Okay. Interestingly, we don't have one. Probably, I think we fixed it. Alright, catch. You will try here. Okay, wait. We should close this here. Alright, and then there should be a catch. Catch ends right here. This catch is ending right here. This should be fine. We really need one more. Sorry about that. This is because of curly braces. Okay, seems like we have a bug here. Wait, I think the while is not closed. Now I close the while here. Yeah, the proper indentation helps. This is good. This is good, and I have this extra. Alright. Now we will compile this program. Sorry. CLS Java C read file dot Java, and then you will run read file. Oh yeah, so this works, right? Sorry about that. The bugs that I had, it's very common. So these were the contents, and we are able to read these contents, right? So the files are not difficult. These are going to be the simplest question in your test. What you need to remember is that you will have to use some classes like scanner class, file class, and then it depends, and then you'll have to use file not found exception also. You need to use exception with the files. Alright, the compiler will force you to put the the file opening statements in the try block and have the corresponding catch. If not, you'll get the errors. We just saw that. Okay, fine. So we are done with reading from an input file. Now let's look at writing the file. So writing is little involved. What I should do, let me take you back to the lecture slides just to make sure that I'm not missing some important concepts. Okay, we have done all these things. Fine, I covered this thing, I covered this as well. Okay, so reading the file has been done. So here what you're looking at is a general code which says that you need to write the code for reading a file in try and catch block. If you don't use try and catch block, you will have the errors. We just saw that. And here let me use pen, blue pen. Now you will use file f is equal to new file. That's what we have done. Now once you create the object file object f, you can pass that file object. You need to pass that file object as an argument for the scanner class to create the scanner object s, and then using this s, now you can read the input in the same way as you were reading from keyboard, right? So in my example, I used a while loop because I wanted to read the whole file. Okay, so you can do the way I did. If you have multiple, you have more than one item in the file, so you loop till you find all the elements in the file. Now catch, I wrote catch with the exception file not found exception. You can also use IO exception, and IO exception is the parent class of the file not found exception. Okay, so now writing to file is little complex because here you will need two more classes, the print writer and the file writer. So I'll go over these nodes and then I'll do a demo. So this is slightly more complicated than reading from a file because here we need two more files, as I said, print writer and file writer. So why do we need print writer? So print writer actually collects all the data that you want to be printed on in a file. So that's something print writer will collect. And the file writer will later on come into play when we want to ultimately store that data which print writer has collected to a file. So print writer actually adds all the data to the file. Okay, so interestingly, this print writer class that we have, it has methods like print and println. And print and println method we have already seen, system.out.print, system.out.println. So once you define print writer object, then using that object you can use the statements like print and println, which will work exactly the same way, but with the print writer object it will be printing or storing the contents in the file rather than on the screen. Alright, so what print writer does, print writer stores all the data that we want to write on a file into a memory called as buffer, and it will keep on storing the information in the buffer until the buffer gets full. It will hold the information until the buffer is full, and after that, once the buffer is full, then it will send that out to the destination, which is the file writer. If you want, you can also force it to send the content that it has in the buffer by using flush. Alright, so we will use that flush also. When the buffer is full, print writer flushes, empties its buffer and sends the data on the destination. We can also tell print writer to flush its buffer. Flush means write that to or send that to the file writer to ultimately write that on the file. Okay, so what is file writer? File writer is a subclass of output stream writer. You don't need to get into that detail. You should just remember that we need file writer, so that using that we could ultimately write the content to the file. Okay, so it will accept the contents which print writer has stored and will ultimately write those to the file. It writes bytes to the file. We can also specify whether, okay, yeah, so sometimes, again I'll show that in my demo, sometimes we want to erase the content of the file and write everything from the scratch if the file already exists. In some cases we want to append to the file, that means the file already had some contents and we want to add some contents or append the contents towards the end. So that is also possible. There is one and there's an argument which we can specify. We need to say true, and after that it will append. I'll show that in the demo. So we can also specify whether we want to append to a file or we want to overwrite a file if the file is already there. If the file is not there, then the program will create a file and will write the contents to the file. And if the file already exists and you are writing to the file, then you have two options possible. Do you want to erase the content of the file and write new contents? That is one option. The second option is if you want to append to the contents of the file, right? So both the options are available. Okay, so it's right here. When you use file writer, then you can specify true. If you say true, then that means you are appending. If it is not mentioned, then that means you are erasing the contents. So you have the program right there, but I will rather prefer writing a demo for you so that you could follow along. I'll take you to this Sublime and we'll write program here. Before that, I'll show you that in my directory I don't have any file named output.txt. So I'll create a file with the name output.txt and we'll write in that file. Okay, so just to save some time, I'll copy the contents of read file to the write file, and because a lot of things are common, write file. I won't need scanner, right? Scanner is something which you need only for reading the contents. I won't read. I'm just writing a program for writing. But in exams, you might expect a question which may involve reading and writing as well, right? So you can do that, right? Write two methods or have the code for reading as well as writing in the same program. Okay, so you need a file class, you need exception class, you also need import java.io.unit file writer class, and similarly you will need print writer as well. Okay, let me write print writer. So these are the two additional classes that we need when we want to write to a file. Cool. So now I need to change this file name. I want to create an output file. So output file is not there. One more time I can show you that I don't have anything like output.txt here, only input, which I created for the previous demo. Alright, so I don't need any scanner, I don't need this thing, delete that. Okay, so file object you need so that you can write to the file. So what will happen here, right here I don't have the file with the name output.txt, so a file object f is created for a new file output.txt. Now you need to declare file writer fw is equal to new file writer f. So this sequence is important. Please remember this sequence, because in this sequence we will have three classes involved. File class, the most basic one, which you need to create so that you have the file object, and that file object is ultimately used either for reading or to writing. Reading from a file or writing to a file. For that you need to create a file object. And the constructor for that is very simple. You need to specify the name of the file, input file or the output file. Using this file object, you will create a file writer object, and this file writer object will accept this file object that you have created on the line number 8. So this is also pretty straightforward. So that's the reason I was saying that questions on files would be very simple if you follow along. Okay, now then comes this thing, print writer. Print writer will use the constructor print writer, and interestingly this print writer will take the argument as file writer. Okay, so this sequence is important. As I said, file f is the file object, print writer fw, the file writer fw will take the file object as an argument, and then the print writer that you have, the print writer will take the file writer as an argument. Now when you are done with these things, when you have taken care of these things in the proper sequence, now is the time to write some content in the file. So for that I will use print writer dot println, and let's write some content. First line of the file. Okay, I need to write something, so let's have 5 lines. If you want, you can have more, or you can make it more general. First line of the file. You can use a for loop if you want. Third line of the file, fourth line of the file, and then you'll say fifth line of the file. Okay, so I want to write only these 5 lines, so that's the reason I have these 5 statements. After that, the most important thing is pw.flush, so that the contents that you have in pw are ultimately passed on to the file writer, and the file writer is writing that in your output file. I think we are done. Let me run it. Java C write file.java. Okay, new, we have an error here, must be caught or declared the thrown. Okay, wait a second. Try is there, dot flush. Let me see where exactly do we have this except on line number 9. Line number 9, it is on try. File writer f, print writer pw, try and catch. File writer. Okay, file writer we have. Wait a second. New file, yeah. So IO exception. Okay, so got it. Seems like the exception should be IO exception, not file, not font exception. Sorry about that. I will say IO exception. All right. Yeah. We need to be very careful about the kind of exceptions. So here it has to be an IO exception. Okay, so Java. All right. So now I should check whether I have output.txt or not. File right here, and you can see that I have these 5 lines of statements. Now one more thing I can do here, whenever we were doing this thing, I can say true. When I specify a file writer with f and the second argument is true, then it will append. So already I have these 5 lines in my output.txt. If I run it one more times, I expect to see 5 more lines added to that. Alright, okay, let's go back. I will have to probably open that again. Right, so now you can see that I have 10 lines, 5 lines, and then those 5 lines repeated again. That was possible when I had one more argument. Sorry about that. When I had one more argument which was true. Okay, so now with that I believe I'm done with this chapter, and yeah, a lot of interesting stuff to read. And we have a similar code right here which you can try, but I think I have covered all these things in my demo. Alright, thank you so much. I'll see you in the next video lecture. Bye bye, take care.